Please make a correction. There's a 0 missing. This should be 2,180,000. In 1980, about 2,180,000 U.S. workers worked at home. During the next 10 years, the number of workers working at home increased 5% per year. Write a model giving the number W, and we're going to cross out this in millions. We don't need to convert these numbers. Write a model giving the number W of workers working at home T years after 1980. Okay, first of all, identify the initial amount. What is the initial amount? 2,180,000. That's going to be A. Skip over growth factor, the annual percent increase. What is the percent here? 5%. How do we change 5% to a decimal? 0.05. Make sure you move the decimal 2 places to the left, or do 5 divided by 100 to tell you what the decimal is. The growth factor, when you look at the growth model, the growth factor is all of the stuff in the parentheses, 1 plus R. So what is 1 plus 0.05? 1.05. All right, part B, write the model. The number of workers equals 2,180,000, or you could do 2.18, and then just remember that your answer is written in millions, times 1.05 raised to the T. Estimate the number of workers working at home in 1990. How many years after 1980 is 1990? So we are going to use T equals 10 and plug it into the formula. So in your equation, 2,180,000 times 1.05 raised to the 10th. Plug that in your calculator, see what you get. If you plug this into your calculator correctly, you should get 3,550,990 workers. Number 7, I didn't read this morning before we actually did this first hour, and I realized after I read the problem, we're talking about poop. Yep, we're talking about poop in math class. There are 40,000 homes in your city. Each year, 10% of the homes are expected to disconnect from septic systems and connect to the sewer system. I think I might rewrite this problem next year. So it says each year 10% of the homes are expected to disconnect from cable service. I feel like that's more relevant to right now. And I feel like you guys don't care about septic systems and sewer systems, but whatever. So we are disconnecting. That means we are going to use an exponential decay model. The decay model is the initial amount times 1 minus the percent decay, the decay rate, raised to the T. So what is our starting amount? So that goes first. And then 1 minus, what is our percent decrease? 10% decrease. How do we write 10% as a decimal? 0.1 raised to the T. If you want to go further and simplify what's inside the parentheses, you can. So this would be 0.9 raised to the T. On your own, for part B, use the model to estimate the number of homes using septic systems after 5 years. So plug in 5 for T. You should get 23,620. Okay. So far we've done straight up exponential growth model, exponential decay model. Now we're going to get into a financial use of the exponential growth model. This formula that's highlighted is the exponential growth model. If you look in it, you can still see a number times parentheses. The parentheses have 1 plus R in them raised to the T. But there's this other letter N in there. N is used in compound interest applications. Compound interest is like you put money in an account, and instead of them just calculating interest and adding it in, at the beginning of a month, they'll calculate interest, add it in. The beginning of the next month, they'll calculate interest on your new balance and add it in. The next month, they calculate interest on your new balance and add it in. Compound interest means that you are earning interest on your interest, along with everything else that's in your account. So it's kind of a cool thing when you can earn money on interest. A stands for the amount in your account after a certain amount of time. P stands for the amount that is deposited in your account. So P stands for principal. It's the initial amount. It's still the initial amount, just like it was in the growth model. R is your annual interest rate, and N is the number of times the interest is compounded in a year. And it's not written here, but T is the amount of time in years. So if it says your interest is compounded annually, how many times per year is annually? Once. Monthly, how many times per year is monthly? How many times per year is quarterly? Don't think too hard. Quarter? 4? Quarterly is once every 3 months, but quarterly means there are 4 quarters, so 4 times per year. Weekly, how many weeks are in a year? Okay, personally, I will not use biweekly with you because some people tell me that biweekly means twice a week, and some people tell me biweekly means every other week. If it's an example like that, I would make it super, super clear every other week, which means 52 divided by 2, or twice a week, which would be 52 times 2. So I will make that one clear. I don't want to use the term biweekly because it's confusing. Daily, how many times per year is daily? 365. So you deposit $2,300 into a bank account. Find the balance after 3 years. If the account pays 3.5% annual interest, compounded quarterly. So what is our principal? What is our starting amount? $2,300. What is our interest rate? How do we write 3.5% as a decimal? 0.035. Single-digit percents must have 0.0. If you need a little helper guide over here, here's 3.5%. You move the decimal 2 places to the left and get 0.035. Or take your percent divided by 100, and that will give you the decimal every time. The N value, the number of times that we're compounding, is quarterly. That means N is going to be 4. And our time is 3 years. Let's plug all of these pieces into that formula. You have 2 options for plugging this into your calculator. You can do this all in one step. If you do this all in one step, you need to put parentheses in exactly where you see them. If you do this step by step by step, you have to follow correct order of operations. So you would have to do 0.035 divided by 4, hit enter. Then add 1, hit enter. Then raise it to the 12th, because 4 times 3 is 12, and hit enter. Then multiply by 2,300 at the end. And a lot of people screw up the order of operations, so it's really a better idea to just enter this all in one step. So 2,300 parentheses 1 plus 0.035 divided by 4, close your parentheses, raised to the, if you have a scientific calculator, you should use another set of parentheses now. 4 times 3, close your parentheses. So if you have a scientific calculator, it's a really good idea to put a second set of parentheses around your exponent to make sure that you get the numbers in your exponent multiplied together before the exponent is done. And then hit enter. You should get $2,553.47. So notice that you started with $2,300 and after 3 years you have earned like $250. In reality, when you put money in a savings account, they don't give you 3.5% annual interest. They give you like 0.5, maybe. Now, if you take out a loan, they're going to give you like 4 or 5% interest because that gets them money. So if it benefits you, it's going to be a super, super low interest rate. If it benefits them, it's going to be a much higher interest rate. All right, the next one, let's do compounded, monthly. I want you to try B on your own. 1.95% annual interest compounded monthly. Okay, if you set it up and entered it in your calculator correctly, you should get $2,438.45. We compounded monthly, which in the long run will give you more money in interest, but it's a much smaller interest rate, so you aren't earning as much money. So over the period of 3 years, it looks like you earned, a little over $130, $138. Your assignment today is on page 300. Numbers 9 through 17 odd. And the reason I'm including this on the video is I want to make sure everyone hears these directions. On numbers 9 through 17, the directions say, determine whether it's exponential growth or decay and graph the function. Don't graph the function. That's way too much work. I really just want you to identify, is it exponential growth or exponential decay? That's it. Then do numbers 21, 23 through 24, and 41 through 43.